Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about substitution for definite integrals.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, the integral from -1 to 0 of 8x over 4x squared plus 1 squared dx. And we're given a u value of 4x squared plus 1. And we want to express this integral in terms of u, but we're not going to evaluate it. So first thing is, since we're already given a u value, let's go find our du value. Du, the derivative here of 4x squared plus 1, is going to be an 8x dx. Okay? Now luckily for us, we can see we have a du right here, 8x, and dx is my du right off the bat, and right here is my u value, my 4x squared plus 1. Now what's tricky is when we're writing this in terms of u, right, we've done this before, we have the integral here, and we're going to write this as, well, 1 over u squared, then du, right, lines up. What's tricky here is, well, for integration from -1 to 0, what do we do with those values? Those values are in terms of x. Well, what we do is we take our u value right here, and we're going to plug in 4 times, and instead of x, we're going to put a -1. We're going to find what u value corresponds with it. So -1 squared plus 1. And then from there, we're going to simplify. 4 times a -1 squared, -1 squared is +1, times 4 is 4, plus 1 is 5. And we're going to do it again with a second one. We have u2. We have 4 times the upper bound, 0 squared plus 1. 4 times, well, 0 squared is 0, times 4 is 0, plus 1 is 1. And so now our bounds, make sure it lines up. We have to go from 5 here to 1. And I know it almost seems backwards, we're kind of going from right to left, but that is okay. And that's it. We have written our equation, our definite integral in terms of u. So our final answer here is the integral from 5 to 1 of 1 over u squared du. We're given this problem right here, the integral from 0 to 1 of a -12x squared times a 4x to the third power minus 1 to the third power dx. And we're given a u value of 4x to the third power minus 1. And we have to express this definite integral in terms of u, and we're not going to evaluate it. Well, we have a u value, so right off the bat, I'm going to find my du value. And that's going to bring down the 3 times the 4, the derivative here. 3 times the 4 is the 12, x squared dx. Okay? And this actually works out pretty much in our favor. We have a 12x squared right here, dx lines up, that's my du. We can see that right here. And my u value is what's inside of the parenthesis. So we'll write this in terms of u, but we're not going to evaluate. So let's go rewrite this here. We have the integral. I'm not putting my bounds from 0 to 1. We'll see in a second. My u value, or du, is a 12x squared dx. And my u value is inside of the parenthesis. So we have just, well, a u to the third power du, but don't forget that minus sign stays out front. So we have a -u cubed du. Pretty easy. But what about these bounds from 0 to 1? Well, those are in terms of x. We are now writing the integral in terms of u. So what we want to do is rewrite this and plug in our x values into u here to find what the equivalent u value is. So we have 4 times 0 to the third power minus 1. Well, 4 times 0, or 0 to the third power, 0 times 4 is 0, minus 1, -1. U, that's mu, whatever. Not really mu, but anyway, u2. We have 4 times the second bound is 1 to the third power minus 1. Okay, well, 4 times, or 1 to the third is 1, times 4 is 4, minus 1 is 3. So our bounds now go from a -1 to 3. And there we have it. Our final answer here as this integral in terms of u is the integral from -1 to 3 of -u cubed du. We're given this problem right here, the integral from -1 to 2 of 6x times x squared minus 1 to the second power dx. And we're given a u value of x squared minus 1. And we have to express this definite integral in terms of u, but we're not going to evaluate it. Well, we have u already, so let's go find my du value. Derivative of u, 2x dx. Pretty simple. And so let's go see how this applies to my integral here. My u value clearly is what's inside of the parenthesis. And my du is both pretty close. We need a 2x dx. We have a dx, we have an x, but we have a 6. 6 breaks down to be a 3 times a 2, right there. Okay? So if we combine the 2x and the dx part right there, we have our du. All right, so let's go write this integral in terms of u. I'm not going to put my bounds yet. So we have a 3 out front. We have 3. Then we have the u squared, and then the du right there, right? U is right here, squared, and then the du is that 2x dx. And the 3 just comes down. So what about these numbers right here, -1 to 2? Well, those are in terms of x. We want to find them in terms of u now, because we don't have x here. So to do that, we use what we know of u to be u1. And let's go plug in our lower bound of -1. Squared minus 1. Let's go find it in terms of u. Well, -1 squared is, well, +1 minus 1 is a 0, right there. The second one here, same thing. We have a 2 is the upper bound, 2 squared minus 1. 2 squared is a 4, minus 1 is a 3. So our integral now, in terms of u, is between 0 to 3. And there we have it, our answer here. So our final answer here for our integral in terms of u is the integral of 0 to 3 of 3 times u squared du. We're given this problem right here, the integral from 0 to 1 of a 24x over 4x squared plus 4 squared dx. And we're given a u value of 4x squared plus 4. And we need to express this definite integral in terms of u, but we're not going to solve it. Well, we have a u value right here, so let's go find my du value. Well, derivative there of 2 comes down, times 4 is 8, so we have an 8x, don't worry about the 4, dx. Well, we have our du value, let's see how it applies with our integral right off the bat. Right here we see a 4x squared plus 4 as our u value. My du is 8x dx. We have a 24 right here, pretty close. We have an x dx, but 24. Well, 24 is 3 times 8, and there we have it. We see the 8x right here, dx being the du. So we can rewrite this integral. Don't worry about the bounds yet, from 0 to 1, ignore that. And we have a du value, 8x dx, and a u value down here of 4x squared plus 4. So we have a 3 left in the numerator, 3 over u squared du. But what about our bounds from 0 to 1? Well, those are in terms of x. We're now in terms of u. So we're going to take what we know of u, call it u1, and we're going to plug in our lower bound 0 and for x to find its equivalent with u. 4 times 0 squared plus 4. Well, 4 times 0 squared is 0 plus 4 is 4. Great. Lower bound is a 4. u2, same thing. 4 times upper bound 1 squared plus 4. What do we have? We have 4 times, 1 squared is 4, plus 4 is an 8. Okay? So we have an upper bound of 8. And there we have it. We have our final answer. Our integral now in terms of u is an integral from 4 to 8 of 3 over u squared du. We're given this problem right here. The integral from -3 to 0 of a -8x over 2x squared plus 3 squared dx, and we're given a u value of 2x squared plus 3. And we want to evaluate this definite integral. Now we're already given a u value, so let's go find my du value. My du value right here, I want to find the derivative of u. 2 comes down times 4, or times 2 is 4, so we have 4x dx, right there. Okay? So with that, we want to see how we can write this in terms of u. Well, right now my u clearly is that 2x squared plus 3. My du is a 4x dx, but we have an 8x dx right here. Well, 8 breaks apart, right, to be 2 times 4. And now we see our 4x dx being the du right there. Okay? So what can we do? Well, we want to rewrite this. I'm going to ignore these values right here. Let's write this in terms of u. Well, we have a -2 left over u squared du. Not bad. But what about our bounds? We were bound from -3 to 0, but that's in terms of x. Well, to change this, I have my u value in terms of x, and I'll plug my negative 3 in for this x to find it in terms of u. So we have 2 times a negative 3 squared plus 3. And what does that come out to be? Well, 2 times negative 3 squared plus 3 is a 21. So 21 now is the new lower bound. Let's do the same thing with the upper bound. 2 times the upper bound being 0 squared plus 3, and that comes out to be a positive 3. So our upper bound here is 3. So now this is a much easier integral to solve, the integral of from 21 to 3 of negative 2 over u squared du. This integral, when we integrate it, comes out to be 2 over u, and we're integrating it from 21 to 3, right there. Okay? Well, from there, we need to plug in 21 in for u and 3 in for u and use our rules here. So 3 goes in first, so we have 2 over a 3 minus 2 over a 21. With that being said, 2 over 3 minus 2 over 21 comes out to be 4 over 7, which is approximately a 0.571. But there we have it. We integrated our integral in terms of u and then solved it. Our final answer here became a 4 over 7. We're given this problem right here. The integral from 0 to 1 of 16x over 4x squared plus 4 all squared dx. And we're given a u value of 4x squared plus 4. And we have to evaluate this definite integral. Well, we're already given a u value, so let's go find my du value, the derivative here. Derivative of 4x squared plus 4. 2 comes down to be multiplied by 4 is an 8. So we have an 8x, and then a dx. Okay? Well, we have our u and du, or u and du. Let's go see how it applies. Clearly we see a u down here, 4x squared plus 4. My du, not so clearly. We have a dx right here, we have an x, but we have a 16. 16, though, is a 2 times 8. And there we see our du. We have the 8x right here, times dx is my du. So we can rewrite this integral. I'm not going to write it in terms of 0 to 1 yet. And we have a 2 left in the numerator over a u squared du. But I need to find my bounds from 0 to 1. So I go back to my u value here, u1. I'm going to plug in 0 in for x to find its equivalent in terms of u. 4 times 0 squared plus 4. Well, 0 squared is 0 times 4 is 0, plus 4 is 4. Not bad. So our lower bound here is 4. Same thing, 4 times upper bound 1 squared plus 4. And this comes out to be, well, an 8. So we have an upper bound here of 8. And now we have an integral in terms of u that's much easier to solve. The integral from 4 to 8 of 2 over u squared du. So let's go solve it. What is that integral? Well, 2 over u squared integrates to be a negative 2 over u. And we're integrating this between 4 and 8. So we plug in our 8 value for u and our 4 value for u and subtract them. So 2 over 8 minus a negative 2 over a 4. Okay? Now remember that's plus a positive here, right? So we have 2 over 8, or negative 2 over 8, minus a negative 2, or plus a 2 over 4. And that comes out to be a positive 1/4. And so that is a decimal, you should know 0.25 right there. Sorry, I lost my spot for a second. I was confused. Anyway, our final answer here from our integral in terms of u is a 1/4. We're given this problem right here, the integral from negative 1 to 0 of an 18x squared times 3x to the third power plus 3 all squared dx. And we're given a u value of 3x to the third power plus 3. And we need to evaluate this definite integral. Well, we have a u value right here, so let's go find my du value. The derivative of 3x to the third plus 3 is, well, 3 comes down, multiplies by 3 is a 9. 9x squared dx. Don't worry about the plus 3 there. So we have a 9x squared dx. Let's see how this can be written in terms of u and du. Well, right here, we see my u value pretty clearly. My du is pretty close. We have an x squared, we have a dx, but we have the 18 instead of a 9. 18 breaks down to be 2 times 9, And there we have our dx, or du value. 9x squared dx is my du value right there. So let's go write this in terms of u. Now I'm not going to include my bounds yet. We have a 2 left over times a u squared du. Not too bad. But notice I didn't write my bounds down here from -1 to 0. And that's because these bounds are in terms of x. We need to write them in terms of u. So we take what we know to be u, and let's plug in our values, -1 for x, to get it in terms of u. So 3 times -1 to the third power plus 3, and that comes out to be a, well, 0, right? And -1 times the third power is -1 times 3 is -3 plus 3, 0. U squared, same thing, 3 goes in. We have 0 as the upper bound, 0 to the third power plus 3, and that comes out to be 3. So we have our integral now from 0 to 3. And so now we have the integral from 0 to 3 of 2u squared du. So let's go find this. Well, the integral here of 2u squared is a 2u to the third power over 3. And we're integrating this from 0 to 3. Well, our rules state we plug in 3 first, and then subtract when we plug in 0. So we have 2 times 3 to the third power over 3 minus 2 times 3 to, not 3, got ahead of myself, or behind myself. Plug in 0 now, 2 times 0 to the third power over 3, and let's go subtract that. This comes out to be an 18 minus a 0. Right, this first part becomes 18, this part becomes a 0, 18 minus 0 is 18. And there we have it, right there. Our integral now, in terms of u, came out to be a final answer of 18. We're given this problem right here. The integral from 0 to 1 of a -8x over 4x squared plus 2 all squared dx. And we're given a u value of 4x squared plus 2. And we need to evaluate this definite integral. Now, they're already giving us the u value, so let's go find my du value. The derivative of 4x squared plus 2, we take the 2 times the 4, get the 8. We have an 8x, ignore the 2, goes away, dx. Pretty simple du here. So see if we can write this integral in terms of u. Well, we have a u down here that gave us the 4x squared plus 2. My du, we have 8x dx, right here, pretty simple. So we can rewrite this in terms of u. Integral, ignore the 0 to 1 right now, and we have a negative, don't forget it, 1 over u squared du. Now we have to change our bounds from 0 to 1 is in terms of x, we need it in terms of u. So we take our u value, u1, 4, we put the lower value of 0 in for x. And this will help us, or get us, the integral in terms of u and our bounds. Well, 0 squared is 0, times 4 is 0, plus 2 is 2. We do the same thing, the second value of being a 1, plug it into our u value. 1 squared 1 times 4 is 4, plus 2 is 6. And now we have a much easier integral to solve, the integral from 2 to 6 of a -1 over u squared du. So what does this integral turn out to be? Well, the integral of -1 over u squared turns out to be just a 1 over u, and we're integrating this from 2 to 6. Well, our rules state we plug in 6 first, so we have 1 over 6 minus 2, 1 over 2. Pretty simple there. 1/6 minus a 1/2 comes out to be a -1/3, which is equal to a -0.3, repeating. Okay? I prefer -1/3. And there we have it. Our final answer here, when we evaluate this definite integral, we convert it in terms of u, we got a final answer of a -1/3. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.